Hello and welcome to my YouTube channel Technical Intercepts. In this video I will explain you decimal number system and its conversion to other type of number systems. In a general rule, decimal number system can be converted to any other form of number system by just following a simple method called double dabble method. In double dabble method, we actually have two operations. One is successive division and the other is successive multiplication. Successive division is done to the integer part of decimal number and successive multiplication is done to the fractional part of decimal number. If a decimal number is given in the form of floating point, then you must have a point in that. It means it is divided into two parts. One is integer and the other is fractional part. So let us see how this double dabble method is applied to our decimal number so that it is converted to other type of number system. Whatever you may say, like binary, trinary, quinary, hexanary or hexadecimal, octal on pen and paper. So if you consider an example, for example, consider 11.75, a number in decimal number system, and you have to convert it into some base value b number system. What you have to do is take the integer part and divide that integer part with the base value till you get a remainder, and this remainder should be less than base value. And read upwards, read and write remainder values. So you will write from here, you will write upwards. Similarly, now take the fractional part. What you will get? 0.75, and perform successive multiplication with the base value b, and you will get some result here. And then after, in that result also you will get some fractional part, say xy. Here you have a integer part, say capital A. Ignore in this ignore integer part value, perform successive multiplication. And only consider the fractional part, like take 0.x5 here. Here we are ignoring the value of a, that is integer part. Now perform successive multiplication till you get a value which is less than a base value, and read upwards and read downwards and write only the integer part in your answer. So let me take an example, the same example here. 11.75, a decimal number, and I am trying to convert it into binary. Binary base value is 2. So perform successive division to the integer part, and the integer part here is 11. 2 5s 10, you will get a remainder 1. 2 2s 4, you will get a remainder 1. 2 1s 2, you will get a remainder 0. 0 is less than the base value 2. So read upwards. What you will get? 1 0 1 1. This is the equivalent value of 11 in binary. Okay. Now take the fractional part, 0.75 into the base value. Perform successive multiplication. What you will get? You will get uh, 0.5. Sorry, 1.50. Okay, and ignore the 1.50 and ignore the integer part. So ignore 1 here and write only 0.5 into 2, which is equals to 1.0 again. Ignore the integer part and write only fractional part. Here the fractional part is 0. If you perform multiplication with the 0, you will get again 0. Now you reached a value which is less than base value. So read upwards. Read upwards only the integer values, that is 110. Now club these two, 1011, put a point in between 110. This is the total value of 11.75, a decimal value which is converted to binary value. 11.75, a decimal value is converted to binary value. This is the total value of 11.75 decimal value which is converted to binary value. Read downwards here. In the next class, I'll tell you other type of conversion of decimal number system, that is decimal to octal, decimal to binary. There also you have to perform the double method, but only the base value will change. If you are using binary, you are taking 2 as base value and you are performing the total operations here. But when it comes to octal, you have to take 8 and do the same procedure. So 8, perform division with 8, perform multiplication with 8 till you get a value which is less than a base value, and read upwards here and read downwards here and club those two values. That's it. Thank you.